Hello and welcome to C# 102, Week 5. It is going to be the 17th today, and I'll be here, and so will Gavin.
Yes, I'm here, and I'm in the 18th.
In the what?
Well, it's the 18th for me. I'm in the future.
Ah, yes. Okay, so let's go ahead and fire up Visual C#, and we're going to be talking really quickly here about implicit typing. And
Use var.
I put this specifically in the syllabus because, as I already have been doing to a certain extent, but what I will be continuing to do from this point on is to use implicit typing wherever possible. So at this point, people should be familiar with what implicit typing is. So for example, instead of doing int my number equals 0, we can now do var my number 2 equals 0. So a few rules about implicit typing. First of all, implicit typing must, whenever you use the var keyword. Now the var keyword, again, is not dynamic typing. Dynamic typing is as if you used the dynamic type, which we're not going to be covering. var is implicit typing, and that means that the C# compiler is going to determine the type of our variable for us without us having to explicitly declare it, which is why it's called implicit typing. It'll type your variable to whatever the type of the expression is on the initializer. In this case, it's 0. 0 in C# is an integer literal. You'll notice if I hover over 0, we get a little tooltip saying struct system.int32, which of course is the alias for the int keyword in the C# programming language. So the int keyword is indeed system.int32. It's just a keyword that's built into the language for us. So if you're using implicit typing, you must initialize your variable to something, and whatever type of that variable you have will be used. Now there are some limitations beyond, first of all, you can't have no initializer. First of all, implicit typing only works on local variables. You may not use them for fields. I've seen people try to do that and try to get away with that quite a bit, and you just can't do it.
Why?
Well,
really, why?
It doesn't.
I mean, it's because as I refuse to stop saying about var, the compiler can only work it out if you can. But you see, at that point, I can work it out. So why can't the compiler?
It was just a design decision made by the C# team. And frankly, I don't miss implicit typing on field initializers because I don't use field initializers, or typically.
No, and it actually is quite a good sort of nudge in the ribs not to use field initializers because you get in the habit of initializing. If you're initializing something, you type var, right. And then of course it says no, you can't do that here. But I just wondered why, because I mean, there's no reason why it shouldn't work like that.
No, there's no reason.
You said that as if that's just the most ludicrous. Of course there isn't a reason.
Well, there isn't. I mean, why do we need... why can't I instantiate blah without parentheses? C# compiler can figure this code out just fine. And we can do it with object initialization syntax. We can omit the parentheses. So why can't we omit the parentheses just in a normal instantiation? And these kinds of language things, I'm a follower of Eric Lippert's blog. He's a senior developer on the C# team. Typically his response is, because the feature is just so far on the bottom of our priority list, we don't want to introduce it to the language, because every time you introduce a feature to a language, that's actually done right, unlike when they introduce features to Cold Fusion, which inevitably end up breaking legacy code quite frequently, which irritates me. The fact is they have to do a considerable amount of testing, considerable amount of documentation, and for what they would consider a frivolous feature, they're not going to spend the time to do so. So no implicit typing on fields. No implicit typing on return types of functions, or methods, sorry. That will not work. No implicit typing on parameters. Now, if you're curious about being able to do implicit typing on parameters and return value types, look at F#. F# actually provides implicit typing to a ludicrous extent, to where if you do things right and play your cards correctly, you can get a fully functional F# program without a single type annotation. It's because it was just built into the F# language specification. It takes a lot of work to do implicit typing, where the implicit typing engine has to look forward in your application. That takes a lot of work from the language designer standpoint, and that work just simply has not been done on C#, and I would doubt if it will ever be done on C#. Not only that, in F# you can omit generic type arguments, because it'll also figure things out for you.
And you'll have a B natural instead of a B#.
I don't get it.
No, done did.
Like, for example, F# you can do like var list equals new list, and then pass in like nothing into the generic type argument list, and then do like add 10, and it will correctly figure out that the generic type argument is 10, or is an integer, which is neat. Okay, so
we may be wondering something somewhat from the subject of just var.
Well, there's another limitation. The next limitation is, although it's perfectly acceptable to do A1 equals 10, A2 equals 20, this is perfectly acceptable code, because we're declaring two integer variables, and we're assigning them both with initializers. This code is...
Don't do it. Please. Please don't do that.
This is not possible to do with implicit typing. This limitation actually does have a reason, because what should things get typed to in this scenario? Some people, they actually did go around and they asked, when they implemented this feature, they kind of asked people what they think should happen, and there was multiple results. This has a level of ambiguity, because should both of these variables be typed to integer?
Double.
Double, or should this be typed to an integer and this be typed to a double? They got so many different responses from people they asked that they decided that this would introduce too much ambiguity in the language.
I don't like that common syntax anyway, frankly.
I don't find myself
even when you are allowed to do it. I find it clearer to read, just clearer to see, to have each separate thing on its separate line.
If I do that sort of syntax, I'll do something like int a1 equals 10, a2 equals 20, something like that, which kind of defeats the purpose to begin with, but whatever. I don't use it very often. Okay, so let's do some quick questions, or questions on my end, and of course people are free to have questions appear in the questions panel.
I would just like to say good evening to James, because he always says good evening to us.
Ah, good evenings, good evening,
wow.
James. Okay, what is the type of bleh? Anybody go. Go, go, go. Go quick, fast. Type of bleh. Type of bleh, type of bleh, type of bleh.
Anybody.
Okay. Type of bleh. Go. Type of bleh. Go. Or, sorry, now type of bleh. The type of bleh becomes stuff. It does not become iStuff. Okay, what about type of this parameter, type of stuff, or sorry, type of stuff. In this case, stuff is going to be typed to an iStuff. On line 25, we get an implicit conversion from the stuff type into an iStuff type. You'll notice here we're using implicit typing. We're instantiating a new stuff. Now, the implicit typing is going to use the most specific type available in this expression, or at least the most specific type available in a instantiation expression, or using the new operator, will always result in whatever we newed up. In this case, we newed up to stuff. We did not new up an iStuff. Now, iStuff does implement stuff does implement iStuff. However, when we do the implicit typing, ble becomes typed to stuff. If you hover over var, you'll notice that it is indeed typed to stuff. When we invoke hey on line 25, we get an implicit conversion between the stuff variable right here on line 24 to the iStuff parameter here on line 28. As a result, the type of stuff over here is iStuff and not stuff. Yes, everybody answered this correctly, so I didn't bother with going over it. This does, but I probably should have for the sake of people watching this video. So people watching this video, this does return ble into a string. And it turns it into a string because of the dot operator being applied to this new instantiated stuff and us invoking the hey method. The hey method returns a string. Therefore, the type of this expression is a string. What's this is really important. I just did those quick exercises really quickly, but and you might think that, oh, this is so obvious. We've had a lot of confusion actually in the past class about what implicitly typed things get set to, and it's really good to be able to distinguish quickly what the type of an expression is. Although, backing up to a more philosophical discussion, implicit typing is in my opinion, very good design for a variety of reasons. One of the most critics of implicit typing will always do stuff like this. Actually, you know what? I'm going to take this. I'm going to stick this method into a different file. Critics of implicit typing will quite frequently pull up an example like this and say that this code is less readable than if I had done string ble.
Well, then they should have called the method getString.
Right. And for example, let's say we have a person type, and the getData returns a person. Again, critics of implicit typing will say that, well, I don't know what this getData returns. I'm going to be looking through this code and not know what this local variable is typed to. And the fact is,
it should be called getPerson.
It should be called getPerson. Not only that, the local variable name itself should be person. Or it should be a more specific local variable name if we're using it for a specific purpose. Or use a comment. I hope that wasn't jest. Okay, so again, sure, everybody is entitled to their own opinions on implicit typing.
Yes, they are, but equally, that's a dumb argument, and it's easily beatable with you name your methods properly, and then you won't have to search through the code to find out what they return. Or, for that matter, you've got tooltips.
Yeah. I mean...
Yes, well, Segfault said.
If they absolutely insist on using ambiguous method names, then they should comment them. If they absolutely insist on using ambiguous method names, they shouldn't use ambiguous method names. Your code should read as comments, not have comments because comments are out of date. Stuff your code with a necessary line. I mean, typically, yeah. If you can express yourself within code by using the identifiers of both your local variables and your method names and your classes to create a language within your own code, then it becomes a lot less useful to use comments. However, getting back on the comment thing, I do make, of course, the exception of when things have unobvious behavior. Generally, I will apply a comment if a reasonable developer looks at my code and wants to refactor in a way that'll make it invalid. So, for example, if I was doing interop with an external web service that had a quirk to it, there's only going to be a few ways to write the code to work properly with that web service, but the code itself is going to look confusing and difficult to understand. At that point, I would put a comment there and say, don't refactor this. This is because of, and then I'll probably put a link to a ticket in that other web service's issue tracker. So yes, I just want to point out that I will be using implicit typing exclusively for local variables, except for in the cases when I cannot. And people might go on the internet and look for arguments for and against implicit typing, and they will find this argument everywhere. And I want to point out that I just wanted to point out that this argument is absolutely ridiculous. Okay, so as long as everybody's good with that, everybody good? Everybody feeling good?
Oh, yeah. So next, curly braces.
Okay, we're going to be talking about collection and array initializers, and we're also going to be talking about object initializers. So I'll go over object initialization first, because this is the most simple possible thing that we can discuss at the moment.
And Dunn said, implicit typing makes me think, and that's just mean. Which is true enough, except you've just got... If you don't want to think, you could always just hover your mouse over var. Actually, you didn't mention that.
I think I did. You hover your mouse over var and you get it. Or if you have ReSharper installed, or other things, you hover over that. Okay. Okay. This bit of code is so frequently used, and the pattern that I'm referring to is instantiating an object and then repeatedly setting properties on it. It's used so often that the Visual C# team actually went ahead and created a built-in syntax to handle the situation as of C# 3, I believe, where instead of doing that, you can do okay, what is this? This is an instantiation followed immediately by these curly braces. These curly braces are only valid immediately after an instantiation of an object or of a class, and they allow you to set each property that has a public setter on that object. This code will literally get compiled into this code. Furthermore, if you did have a... Well, I do want to point out, first of all, you'll notice that I do not have parentheses after this object instantiation, whereas I do on line 20. These parentheses are optional. However, if you have a...
Yeah, as Musaru says, ReSharper will hound you over this.
Yeah. Now, if you do have a constructor, you may use it here. Using a constructor and object initialization is completely valid, and you can use both or one, depending on how your object is set up.
This is called object initialization syntax.
Yep. These properties must have public setters for them to be used like this. Furthermore, you can nest object initializations.
Notice that the lines are separated by commas,
Yes.
not by semicolons.
This is also very important.
And that you need a semicolon after the end of the statement.
Yep.
That's the other thing. It puts the whole thing into one
expression
line of code.
Yep, that's a single expression. And like Gav said, they must be separated by commas. So, yeah, you can nest object initialization if you wanted to. In addition, you can because object initialization is an expression typed to the object you are instantiating, it's not necessarily required that you immediately assign it to a local variable. What I mean by that is I can invoke this bleb method and pass in a person that is built
inline.
Okay, do you need to use the exact order, and is this constructor called before the implicit initialization? Okay, constructors are invoked before the initialization. The initialization will literally result in code that looks like this. Constructors are always called first. Second, the order is irrelevant. You may assign properties in any order. In fact, you can even omit properties, as you see in this example. So any questions about object initialization? And this is where things start to look a little scary, because you'll notice that I'm instantiating a new person and setting properties inside of an method argument. Line 44. Okay, line 44 is instantiating a person and setting the first name property to woe, all in the same expression. So you'll notice if I do p1 equals new person, this code is functionally equivalent. So you'll notice that in this instance, I am doing just what I did right here on line 30, and then passing p1 as a parameter into the bleb method.
Because you're making P1 and then you're not doing anything else with it before you put it into bleb. You can just, it's called inlining that variable.
Yep.
You don't need the variable there because it's just literally somewhere it's an unnecessary step at that point.
Yep. And ReSharper, actually speaking of inline variable, ReSharper has a refactoring for inlining variables that I use quite frequently. Generally speaking, you shouldn't use public fields, and it won't be invalid to assign them using object initialization syntax, so you're more than welcome to. But typically, public fields that are mutable are not something you would want to do. Generally speaking, the only public fields that I'll ever use are read-only, which is something we'll be discussing very soon here.
And in Unity.
Yeah.
Even then you fight it. Well, see, segfault. We'll get to that because that was literally, I said those exact words. I wonder what read-only could mean. What could it possibly, but it doesn't mean read-only. It's stupid. Anyway. We'll get to that in a minute.
All right, everybody good with this stuff? Because I guess we're moving on to collection and array initializers. Okay, well.
And yes, move through the clause came out on that, but that's because I had to fight my way around it earlier today.
Okay, let's first talk about implicitly typed arrays. What's an implicitly typed array? Well, an implicitly typed array is an array that's implicitly typed. And you can do this by this syntax. This is taking advantage of both array initialization syntax and implicitly typed arrays. So typically what you would have is this. Ignoring the fact that I can algorithmically determine these values, I'm assuming that for the purposes of this example I can't. So basically, this syntax becomes this syntax.
If you look through the first syntax, the longhand way of doing it, it's just like looking for places where you can perhaps break something out into a method. You can see instantly you've got all this redundant writing, where not only are you writing essentially the same thing over and again, but you know what that thing is going to be. You can work out what that thing is going to be.
Yep.
You work out R2 from the name of the variable R2, and you convert you know.
So yep. So there's a lot of things missing from this syntax. First of all, we're missing our type specifier for the array. This is implicitly typed array. Now you can mix implicitly typed arrays with array initializers. So I'll start with this example, and then I'll do an R3 where it doesn't have a type. So you'll notice that with an array initializer, you get this nice little thing where you don't have to specify a number here, which is nice, because typically you're going to have to specify a number there. You notice array creation must have an array size or array initializer. So the first thing about using an array initializer is you don't have to specify a number. Now I've never tried this. There we go. So you can, but it must match up anyway with however many items you're specifying in the array initializer. So it's really worthless to place in there. So leaving the number out is much nicer. So you'll notice that the array initializer looks very similar to the object initializer. In fact, it looks, it's pretty straightforward. We initialize an array, and we are sending in 5 values, comma separated, of a particular type. And now in this case, this will coerce the type into the type we specified. So for example, I could specify double here, and this works. This will create a double array. And what's happening here is we're telling it that the array is a double array, but then we're passing in a bunch of integers. Because integers have an implicit conversion into doubles, this code is considered valid, and what will get spat out is a double array. Now on line 20...
That's literally just... I was just going to say, that's literally just saving you writing the 0.0 after each number.
Yes. So...
as opposed to...
what we can do here is by omitting both the type and the number, we can specify an array of items. The C# compiler is going to determine the best compatibility between these different types. And it does a decent job of that. So for example,
that should take in a palm.
So for example, what we'll get here is an error, because, like I said, it'll try its best to coerce all of these types of the things we're passing in, but it's not going to be particularly smart about it. It has some level of intelligence, but not to a great extent.
Well, that's the exact same problem we ran into with var and multiple declarations on a single statement. It can do it if it's an easy thing to work out, but it won't make a decision for you where there's no reason to pick one over the other.
So you'll notice in this case, I added a double, and the array, it became a double array, because the C# compiler and the rules for this conversion are very well spelled out in the specification if you ever are interested in reading that. There's actually, I recommend to everybody, there's a great annotated hardcover book of the C# language specification that contains annotations from some of the major players in C#. But what's happening here is that there is a suitable implicit array type here because we have integers and doubles, and integers are convertible into doubles. Therefore, the C# compiler gives us the best guess, which is going to be a double array. In this case, the C# compiler is not able to work out, even though class 1 and class 2 both implement iface, it's not able to work out that that's the kind of array that we want. So in a situation like this, we are forced to forego implicitly typed arrays and simply specify the type explicitly. And you'll notice by explicitly doing this, it compiles.
But isn't that relatively recent development? I'm sure I remember a radio show at some point where you were excited about the fact that you no longer had to type the type name of an array. When did that? Which version of .NET did that become? Has that always been the case?
No, it's C#3, I believe.
Yeah.
And quick note about versions. Actually, I am going to have a discussion about versioning after we get into...
Yeah, probably a good idea given the mess I've been through with that.
After we talk about the rest of the array collection initializers, I'm going to be giving a quick word about versioning and how that impacts the .NET framework. Okay, so... yes, this is the book that I'm referring to. Great, great book. Highly recommend it. The C# programming language covering C# 4.
And get it on a Kindle, because it's a bargain.
Yeah. Great, great, great book. Okay, so, yeah. How is everybody feeling about implicitly typed? It only has 3 stars because people were thinking it was a tutorial.
And it's not. It's literally the language specification, but with, like, behind the scenes. Director's commentaries.
Yeah.
And blooper reel.
Although some of the commenting is quite entertaining. Okay. Is everybody good with this? And I explicitly, specifically, do you feel good about this, actually?
I feel positively frabjous.
Because you familiarize yourself with the syntax, I will be using it. I will be using it extensively. It won't work when you try to mix and match certain classes that don't have conversion between each other. So that's an instance where it won't work. However, if I were to instantiate 2 class 1s, we will properly get an array initialized.
No, it's not that it doesn't work with classes you make. It doesn't work with classes that it can't tell are the same.
Yep. But you'll notice that when I cast this to an iface, that it does work. Because now this parameter, or this not parameter, but this object, this object has an implicit conversion to the type of this object. All classes have implicit conversions to the interfaces that they implement. So therefore, by specifying one of the things we pass in as an iface, we properly get an ifaced typed array.
And that could be either of them. You could he could quite as easily have converted class 1 to iface.
Yep. But, however, in this case, I would have just done this. Okay, so collection initializers. Collection initializers are fun because we can actually take advantage of them with our own code. So let's talk about list initializers first. List initializers work just like array initializers, but they're for objects. So what we can do is I can instantiate a list and pass in a bunch of values that look a whole lot like array initialization. This code will literally turn into this. This code gets turned into this code. Are there any questions about this? I mean, would you use the array init or list init? Typically, I do. It depends. If I need a list, I'll do the list initializer. If I'm doing an array, I'll use the array initializer. However, if I'm only creating a collection that I'm not going to be adding additional items to, I'll use the array initializer. Just because it just feels a little bit more straightforward. Can you omit the type arguments for the list? No, you may not.
And I don't understand your other question.
I understand it, and we're going to get into it.
Oh, do you?
Yes, very fun stuff. Okay, so what other stuff we can do with this is it works with all other types of initialization. So we can create a var list2 of new list person, and we can pass in person objects that are in addition initialized.
There's not a lot to get hung up on, really, but this, I don't think.
There really isn't. It's just getting used to the syntax, because I use the syntax very, very frequently.
I would say the most common thing I struggled with, or not struggled with as much as just always have to go back and add in, were the commas instead of semicolons, or missing out a comma when I added something, or that sort of thing. And again, there, if you've got ReSharper installed, it will help you a great deal, and it really will shout at you to use initializing syntax for a variety of cases.
Okay, what's the output of this program? Can anybody guess the output? Well,
indeed.
You might be a little bit disappointed to see an exception thrown. I can't believe Segfault got that wrong. That was if you looked really closely.
At line 23, presumably?
On line 23, we are using the collection initializer on our other people collection. Our other people collection is an automatic property of list of person. We never instantiate this. We've never instantiated. So the compiler omits calls to the other people.add method. But because we never instantiate it, and I gave a little hint by saying private set right there, we get a null reference exception. So now if I were to say public person other people equals new list of person, now when I run it, we get what we expected. So basically what's going on is this syntax is a little bit different than the other syntax, because you notice I'm not doing an instantiation. I'm taking advantage of collection initializers in the context of object initializers. So what happens here is the compiler omits an other people.add invocation to this new person. This is literally this code right here.
Did you say omits or emits?
Emits. Emits.
Which one?
Emit. This is the code that the compiler will omit given this syntax. Do you see the problem now? The problem is we're instantiating the person, we're setting his first name, and then we're doing person.otherpeople.add. Now, person.otherpeople.add, unfortunately, is invoking a method on the other people property, and or on the object referenced by the other people property. The problem with other people, though, is that they're not initialized into anything. Because this is how the example was originally. Person did not have a constructor. The list of other people was never instantiated. So when the compiler emits the person.otherpeople.add method, we get a null reference exception. Does that make sense, Wolf?
I love Naked's comment.
So if I run this program, you'll notice I get a null reference exception because the compiler will emit a person.otherpeople.add, whereas the other people list is not instantiated to anything. To make this code work properly, I would have to add a constructor to my person type and instantiate other people to a new list. And by doing so, you'll notice that the code executes properly. So be careful with collection initializers on inside of object initializers.
So have you got something that they could perhaps work on in terms of what we've covered so far?
I can't think of anything, to be honest.
No, I can't. That's why I wondered if you could.
Is it because you're trying to add to a list that hasn't been made yet? Yes, that's exactly what's happening. When given collection initializer syntax in the context of object initialization syntax, the compiler will turn this code into a otherpeople.add invocation. Okay, let's really quickly talk about dictionary initialization. Then it's time for probably a break, and then at that point, we're going to be looking at some really fun stuff we can do with initialization on our custom classes.
You're not going to go into detail on tuple initialization?
No, because that requires talking about generic type inference.
That would get horrible.
So how does everybody feel about this? Not surprisingly, this code inevitably will turn into...
Well, there you could have got them to write out what it would turn into, actually.
Yeah, sure. Okay, I'm going to go ahead and pause the video and ask everybody to write out long form what the compiler is doing given this syntax. And go ahead and also type in this syntax yourself on your own IDE, because this bit, because of the ridiculous amounts of curly braces in it, is something that's worth practicing. So I'm going to go ahead and pause the video. So we are back. So how did people do with the dictionary thing? Okay, so just to code it out really quickly, this code is equivalent to this code. The C# compiler will literally compile this code down to this code. I want to step back for a second and talk about .NET and C# versioning, because this is a topic that people get very confused about. The .NET framework has a variety of different ways that that versioning actually works. And even I've forgotten the exact specifics of, or the intricate differences between some of the versioning. But as a general sort of overview, I really want to discuss this, because this concept impacts people who will be using programs like Unity. If you remember, Unity runs on a .NET 2.0 runtime. Now you might be saying, hey, wait a sec, Nelson, I can compile class libraries to 3.5 and have it dumped into Unity. Well, you can, but 3.5 didn't include a new version of the runtime. .NET 3.5 included CLR2, C#3, and then the rest of the framework was upgraded to 3.5. The .NET Framework version, the CLR version, and the C# version are completely different things. When .NET 4 was introduced, CLR was brought up to version 4, and C# was brought up to version 4. They're two completely different concepts. The fact is that the C#3 compiler, now when I go over here and jump over to right-click and say Properties and change my different targeted framework, when I select .NET Framework 3.5 and .NET Framework 3, this is using the same version of the C# compiler. .NET 4 is a different version of the C# compiler, and .NET 2 is a different version of the C# compiler.
While you're in there, the client profile, because I have seen people handing things in, and it confused me for a while because it threw me an error I didn't understand. But the client profile version, what's that about?
The client profiler is a thing that Microsoft started doing. And the thing that Microsoft started doing was they wanted a smaller installation of the .NET framework. So they introduced what's called the client profile. The client profile is the same language, the same languages, and the same runtime, but it's stripped down in that it doesn't have as many class libraries part of the BCL. Does that make sense?
Well, kind of, but well, why? Why do those libraries? Why would you need the bigger version then?
Well, for example, .NET Framework 4 client profile and .NET 3.5 client profile will exclude system.web, for example. So you'll notice that I'm in .NET 4 client profile. If I want to add references in my references dialog, this list is actually going to be smaller. You'll notice that there's a lack of system.web. There's a system.web.services and a system.web.application services, but there is no system.web. That's because the redistributable package for .NET 4 will include a bunch of additional stuff, whereas the redist package for .NET Framework 4 client profile will be significantly smaller.
Cool.
So getting back to this, so we have .NET Framework 3.5 was built on CLR2 and C#3. .NET Framework 3 was built on CLR2 and C#3. .NET Framework 2 was CLR2, C#2, and of course .NET Framework 1 was built on C#1 and CLR1. Now to get really confusing, .NET Framework 4.5 is built on C#5, and I can't remember if they did an in-place upgrade or a existing upgrade. I could have sworn the CLR was still at 4, if I'm not mistaken, but it could be 4.5.
It does seem like it should have the tagline, .NET Framework versioning, the quest for equality of numbers. They're gradually trying to tie the version numbers together. At which point they'll probably do what everyone else does and give up and go on to naming it by the year or something stupid.
Yep. So, I want to point this out, specifically for people who are working with Unity, because as you know, you can compile a class library for Unity in .NET 3.5, and it'll work in Unity. That's because Unity works under the CLR2, and 3.5 targets the CLR2. However, installing Visual Studio 2008 and compiling an assembly for .NET 3.5 is different than installing Visual Studio 2010 and compiling for .NET 3.5. Or a better example would be 2005 for 3. No, it's 2005 2. Wow, I love the version numbers. Aren't they just awesome?
Stick with the first one.
Okay.
Because you're going back a long ways, otherwise.
I'll rephrase my question, or my statement, because this is important and this is something I want people to understand. If you have a C# 4 compiler and you target .NET Framework 2, you will be allowed to use features in the .NET Framework that were introduced in C# 4 that weren't in 2. And here's why. The feature that we just discussed this code will compile on a version 3.5 C# compiler, or version 3, because there is no C# 3.5, there's only C# 3, even if you're targeting .NET 2. And this is because all what you're seeing here, the implicit typing and the object initialization, is all sugar coding, or syntactic sugar, sorry. Many of the things that you can do in 3.5 are possible to, or in different versions are possible to do when you target against earlier versions of .NET Framework. So, for example, in .NET 4, if you have a .NET 4 compiler or a C# 4 compiler, you can compile using the default and optional parameters and still have that assembly work in a .NET or in a CLR 2 version. So this, I just wanted to point out and possibly dispel some confusion for people who are working with Unity, because I know a lot of our members do work with Unity and might have run into an issue. And I wanted to point this out right here because, frankly, this discussion had no other place in the syllabus, and this is a short class anyway. And not only that, we have been talking explicitly about syntactic sugar. This syntactic sugar is not a function whatsoever of the CLR or of the .NET Framework. This syntactic sugar is a function of the C# language. At the end of the day, this code is going to be compiled down to intermediate language that is able to be executed on the CLR version 2, which allows you to write code like this, compile it in a C# 4 compiler, target .NET 2, and have it run on processes such as Unity. Okay, so that's...
You actually got me wondering whether that's got anything, whether that is at the root cause of the whole thing with why Unity uses public fields instead of properties.
I see where you're coming.
Auto properties came in at, was it version 3?
Auto properties were version 3, yes. C# 3.
You were about to say I'm wrong.
No. Well, I was about to say that properties themselves have been in existence in C# 1. Meaning any C# compiler should be able to understand properties. Yeah. But automatic properties were introduced in C# 3. So I want to point this out. Also, when you hear me talk about C# version numbers, I'm going to use C# version numbers, which right now are 1, 2, 3, and 4, and 5. Not .NET Framework version numbers. So yeah, how's everybody feeling about that? I mean, hopefully I made someone's day by explaining something that was confusing to them, and I realized that it was a kind of an esoteric discussion, something that I did want to discuss because I can.
Are you going to be putting relative version numbers on the test at the end?
Yes, we're going to have a test on this sort of stuff. So, have fun. All right, so what's next?
I don't know.
Oh, yeah. I was going to actually do a really cool thing. Basically, so everybody saw the collection initializers that we had before. Right? Collection initializers that we had before. So for example, we can have a var list equals new list of int, and we can do 1, 2, 3, 4, 5. What if we wanted to use or abuse this syntax on our own classes? Because frankly, all that's happening here is the C# compiler is emitting a bunch of invocations to the add method of this object. Somebody's butting. Okay, well, I guess I am going to ignore people then. Okay, so basically, we can. But it's not so simple. In a perfect world, this would work. But sadly, we don't live in a perfect world. The C# designers, when creating object initialization syntax, originally decided just to have the prerequisite to an object that you instantiate support object initialization syntax, support an add method. But they were like, well, there's a lot of other classes that have add methods that don't necessarily correlate to object initialization. So for example, maybe a math library or something might have an add method that doesn't actually, make sense to put in the context of object initialization. So sadly, you do have to annotate your class with one interface. You must implement IEnumerable of type whatever you're implementing. Now, the actual implementation of IEnumerable is irrelevant in this case. It's something to definitely look at, and we will be looking at this in depth. But simply, I want it to be complete with our collection and array initializers discussion. If you have your class implement IEnumerable, and your class has an add method on it, you may use object initialization syntax with your code, and I can prove it. I can say console write line adding item. You'll notice that I was able to invoke code by using collection initialization with a custom class.
That is cool. And it's a good sort of light introduction to the power of interfaces. The root cause of them. It's that they've said, okay, if we make you implement IEnumerable to do this, it sets out what it is you've got to do in order to make this work. Hello?
Yeah, hello? Hello?
Sorry, you stopped.
No, I was just, pretty much. So, everybody's super stoked on collection initialization? Because I think that's about it.
What if we wanted to make sure that they were, that we weren't putting in two things that were the same, like a dictionary does?
Well, I mean, we could add more code to our add method. So, for example, I can say, I can say list of items instantiated public inventory items.
It's all right. I'm trying to make you write equality members when you haven't got resharper all.
Oh, well, fortunately, I didn't need to do it because I can just say if items does not contain, or if item contains, throw new invalid operation exception. And now if I were to instantiate a key and try to add it twice, I'll get a nice little exception.
Cool.
But inventory IEnumerable contains no code. It doesn't. Remember, the reason that they forced us to implement IEnumerable of whatever was simply, and notice how I'm implementing IEnumerable of int. I didn't even realize that. The fact is, it just wants you to implement IEnumerable of anything. Because they're saying that we only want collection initializers to work on collections. We don't want to have collection initializers work on classes that serendipitously have a add method on them that might not relate to what a collection initializer conceptually is. So they said, okay, well, how do we stop this? Well, pretty much every collection implements IEnumerable, so let's force the person wanting to take advantage of this to implement IEnumerable.
Talking of which, do you just want to fix that for the people who are copying down diligently their examples? The fact that you've, for some reason, done IEnumerable of int.
Yeah, it doesn't matter. In fact, I could even use the I'm pretty sure I can use the non-genericized IEnumerable if I wanted to. We can.
Oh, well, you'd have thought, because I've never are they just a hangover from, because there's non-genericized versions of lots of things that
Yeah.
I've only ever seen them as options to import when I've picked the other one.
Yep. Non-genericized collection types are just cruft left over from C#1. C#1 and in the .NET Framework 1, both the CLR version 1 and C#1 did not support the idea of generics. They needed more time to implement generics in terms of the language. And so that was introduced in 2, and as a result we get a lot of cruft, like IEnumerable of nothing. Okay, so now that I've probably thoroughly confused everybody, but I hope somebody found that interesting. Okay, well, that's good. Oh, Florum was writing that. Okay, I'll bring it back. But we do need to quickly move on.
So what is next on the list?
We're going to be doing some basic... we're going to be basically recapping something I intentionally introduced earlier. Essentially.
Being
the concept of... Yeah, I'll just this. This isn't that super ridiculously important anyway. It is a fun little thing that's worth knowing, and in the interest of completeness, I really wanted to show it. Using polymorphism to support the concept of having different actions on particular items. And this is going to be very useful for our game, essentially. So I'm going to start off with an interface iItem that has a string name property. Then I'll have an interface something like
key
usable, void use. And then perhaps something interface examine.
Examinable.
So now I can create a key which is usable and examinable, I suppose. And it's also an item. So really, this example, what we're going to be covering here, will be a great time for people who, when I introduce this at the beginning of the course, hopefully people will have some more perspective, or at least have specific questions to talk about in regards to this. Okay, so now we have a key, and then let's go ahead and create a...
mural.
You just like throwing out words that you know I can't spell.
M-U-R-A-L.
M-U-R-A-L. Okay.
Well, I specifically picked it because it's a painting on a wall, so you can't exactly...
use it.
Yeah.
Okay.
Something usable that you can't examine.
I
can't think of anything.
Is everybody good with the example so far? Has everybody seen enough interfaces and classes and interface implementation? So we have three interfaces, an item, a usable, and an examinable. We have two classes, a key and a mural. The key implements iItem, iUsable, and iExaminable. The mural implements iItem and iExaminable. Which bit about interfaces are difficult? I mean, is it the lack of access modifiers on the members? Actually, Raymond brings up a good point. Would you ever want to chain interfaces like iItem implements iUsable and iExaminable? I would not want to do it like this. I would not want iItem to implement iUsable and iExaminable, because this will force that all items are usable and examinable. But I do want to make every usable an item and every examinable an item. This is a case of what's called interface inheritance. What interface inheritance is going to do is that when we inherit one interface from another interface, we are forcing that people who implement this interface to also implement the interfaces that we inherit from. So you'll notice by adding these two qualifiers, we get no additional compiler errors, because we happen to have two items that are iUsable and iExaminable, but they are also items. And as a result, the code will continue to compile.
You know what would be really cool on line 24 would be to use the abstract keyword.
Well, you could.
And then you've got a... Well, then you've done fully done that pattern. Its name I can't remember.
Well, I wanted to be able to instantiate this guy.
Yeah, but if you make that abstract, because then you have specific keys that would inherit from that abstract class.
Yeah, so we could have a class red key that inherits from key, and that has a constructor. Now I'm going to give the red key an empty, no parameterless constructor, and then it's going to invoke a base and pass in a key name of red into the constructor of our abstract key class. And then my green key will do the same thing, but with green. Does everybody remember enough about inheritance and how constructors relate to them? Because that's something that we discussed a while back, so I hope people are still more or less familiar with that concept.
Yes, Egfault, this is review. This shouldn't be confusing people. And actually it points out quite nicely the difference I feel between the two. Perhaps that is just me. I like it. It's a nice pattern where you compose your abstract key, and then that's a nice place to be able to have some general functionality before getting specific.
True. And there are situations when I do patterns like this. ASP.NET MVC is a good example, where in ASP.MVC, all the controllers implement iController. But there's also an abstract controller class that gives you some additional convenient functionality. You could completely forego implementing or inheriting from the controller abstract class and instead implement iController directly if you needed more flexibility, and the rest of the system would work just fine. Or if you needed the additional helper methods, simply inherit from the controller class. Wolf, that's actually
the concept of a
good. Well, Wolf does bring up a good point in the questions. Typically, I wouldn't use inheritance just for replacing a property. a single property. I would just instantiate different instances and pass in different things into the constructor. That being said, by doing it this way, it does provide the ability to give different functionality for members. So for example, the use, I can go ahead and make use abstract, and then I can say public override use, and say console write line unlocking red doors, or something like to this extent. So generally inheritance is getting a not implemented error. Which bit of code are you looking at? Line 24, not implemented error. Make sure that you have all of these members, because by implementing IItem, IUsable, and IExaminable, we must implement the string and name property with a single getter and not a setter or a private setter. And IUsable requires a void use method, and IExaminable requires an examine method.
In this specific case, is it necessary to implement IItem on your key class?
Nope. I think it's a little nicer, though. But the good thing about this is this forces people who implement IExaminable to implement IItem as well. So, did you get that fixed, NATO, or?
Oh wow, I was muted.
I was wondering why I was so silent.
I was just saying, yeah, it's nice that they've left you the option, because I can see, yeah, it's more explicit seeing when you look just at the key class definition to have it there. But obviously, it's not necessary because one and, well, in fact, both the others do.
Alright, so missing access modifiers. Alrighty. Interfaces are public, yes. By default, interfaces, or no, what I mean by interfaces are public is all the members within the interface are going to be public. It's not legal to even specify an access modifier, even the public access modifier, because every member of an interface is public. Okay, so now that we have this sort of code, what we can do now is instantiate like an inventory. So a new list of IItem. We can pass in a new red key, a new green key, pass in a new mural with the name of whoa. And I think those are the only objects that I defined. So let's throw in another mural called Hey There. So now I can enter an infinite loop, and I can say console write line inventory bar item in inventory. Console write line. Actually, what I'm going to do is do a for loop.
I've never seen you hit Alt-Enter so slowly.
No kidding. Alright, so basic user interface, and then I'm going to go ahead and say var input equals console read line. Say if or var parts equals input dot split blah 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 on spacebar, and then if parts dot length is 2, if parts 0 equals what do we have? Use and examine. So if that's use, then I'm going to go ahead and say var usable equals, and just to see if everybody's, or first of all, I'm going to say var index equals parts 1. Try parse blah 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 in parts 1 out item index, then go ahead and just continue the loop. And then otherwise go ahead and say if item index is smaller than or equal to 0, or item index is greater or equal to inventory.count. And when I said greater or equal to, I meant just meant greater than, then continue, because we selected an invalid item. Then I can go ahead and say var item equals inventory I minus 1, or item index minus 1. The reason I'm subtracting 1 is because in the user interface we presented it in a 1-based list, and we have to convert it back into a 0 index list.
I think you still got line 110 wrong.
Line 110?
Shouldn't it be less than 0, not less than or equal to 0?
No, item index is going to be 1 through inventory.count because of its 1-based list. Is Segfault talking in BuzzNet? Because I'm not seeing his posts.
I just saw no Gav because it's 1-based.
Yeah, you can see key. It looks like I got somehow kicked out of BuzzNet. I have to submit a file report with whatever idiot programmed it.
Yeah, I blame coded it myself.
Yeah, you're here. I just logged back in. Okay, so here's the abstract key class, which is an abstract class key that implements IItem, IUsable, and IExaminable. Okay, so jumping down really quickly, just finishing off the code that we have here. Okay, so now if I were to run this, I can say use 1, and it says unlocking red doors. Actually, what I'm going to do is I'm going to say console.writeLine, press any key, console read key, and finally console.clear. Okay, so I can say
variable as well.
Hmm?
Just because you copied and pasted, you've now got var usable equals item as IExaminable.
Okay. So in this case, we have a polymorphic inventory where we can use a 1 and we can unlock red doors. We can use a 2 and we can unlock green doors. However, if we use a 3, we don't get anything. In fact, I'm going to go ahead and say else console writeLine Okay, so in this case, if I try to say use 4, I get, hey there is not usable, or use 3, whoa is not usable. But if I say examine 3, I get looking at mural, or if I do examine 4, I get looking at mural, or examine 2, I get looking at key, looking at a key, blah blah blah, and I can use 2 and use 1. So to go through this code a little bit more in depth, I guess, we have three interfaces: IItem, IUsable, and IExaminable. And we can create classes that implement a combination of any of these. Of course, they still have to implement IItem at some point. So, yeah, and that's that. In this case, we also have an example of inheritance being used in combination with an abstract class that implements interfaces. So you'll see that the abstract class key implements IItem, IUsable, and IExaminable, and it does so with this. You'll notice something interesting on line 33. We're implementing an interface member, specifically the use method on the IUsable interface, but we're doing so with the public abstract method. And because it's a public abstract method, it doesn't have a body. However, this still fulfills the interface contract and therefore is completely valid code, which means that the subclasses, such as red key and green key, they can choose, or they can't choose to, they must override that method. And ultimately, at the end of the day, if you try to invoke the use method via the IUsable interface on the key, you'll end up with either line 50 or line 63, depending on the specific object type. So are there any sort of questions about this code, at least the interface, at least the hierarchy that we have right here? Because we do have a fairly interesting hierarchy of objects, or hierarchy of classes and interfaces.
This would be, it would be probably worthwhile whiteboarding this out, actually.
Yeah. Although we are getting close to...
another break.
Yeah. I will whiteboard it out, but actually I'm going to go ahead, just because this is such a long example, I will go ahead and gist it to people. Because you guys don't have the convenience of a pause button. There's no way I'm getting all of this on the same screen.
Yeah.
There isn't anything new on this code. Basically, what I'm trying to do here is I did talk about this on the first week. The second week, when there was this really intense discussion about interfaces. But I'm bringing this back up to see if people are starting to get a better feel for how interfaces work and how to use it in the context of polymorphism. Because this is an example of polymorphism where we have this concept of an item, but an item could, in actuality, be one of any kinds of different objects. And those kinds of different objects will affect the runtime of our code. So I just gisted everything. And I encourage people to copy down. This bit of code is really just boilerplate user input and user output code, or input-output code, but still. Alrighty, so I'm going to
most of what net... Oh yeah, go ahead. And
Arthur, you're going to say something about...
I was just going to say most of what you're trying to get across, you can get from closing all the methods up and just looking at the signatures.
Even that we can't fit on a single screen, but we might be able to fit it on two.
Well, it's partly why I suggested whiteboarding it out, because in this case it's all about how the interconnections work.
Yeah, I am definitely going to be whiteboarding
and
this
so
out.
Have you paused the video?
About to, yes. Okay, and we're back. So I'm going to quickly go ahead and open up Photoshop, and we are going to be talking really quickly about how this code looks if we were to diagram it on a two-dimensional surface. Surface, not service.
Yes, your service infrastructure is irritating. It irritates me.
Irritates? What's wrong with saying irritates? Is that really not how you... That's how every American I've ever heard pronounce it. I don't know. Okay, so let's talk about squigglies.
Squiggles.
Okay, so we have this item, this I item, and it's an interface. We also have a few other interfaces. We have a usable interface and an examinable interface.
They've all got invisible eyes.
Each one of our items are keys, wow, and our murals, what is it, M-U-R-A-L. You know, that's funny though, because that's exactly how I would spell it if I were attempting to, but I just have I lack
I've just
confidence.
given you such a complex about it now. Excellent.
Okay, so IUsable and IExaminable both implement item, meaning that anything that's usable or examinable must be an item within our code. We've enforced that via the language of, or via the way that we've expressed this language. Now we've also made key implement item, and we've had it implement IUsable, and we've had to have it implement IExaminable. However, the mural implements item, and it implements IExaminable. That means any mural object that's assigned to an item, if I were to take an item, local variable, and assign it to a new, let's say, key.
Or even assign a new key to it.
Whichever. This object, this is an object. The variable that we're assigning it to is of type item. But that doesn't mean that we can't go back to a usable if we enter context within our program that we want to see if it is usable. So although this item is currently set to a new key, it can be converted into an IUsable. Here's the important thing. This item type for the local variable is the compiler time type for this particular variable. We can cast it to an IUsable, or rather convert it into an IUsable. And notice we have to use an as operator. There is no implicit conversion between or from item to IUsable. Now there is a implicit conversion from IUsable to item, but there is not an implicit conversion from item into IUsable. We have to explicitly convert, and in this case we're using the as operator.
Do you want to Control Z those last few arrows out?
Is it correct to describing that implementing when it is between interfaces? No. Interfaces that inherit from other interfaces are inheriting. Interfaces can inherit from other interfaces. Classes can inherit from other classes, but classes can only implement other interfaces. This was already discussed, but I do want to... I do want to see, given this diagram right here, if there's any more issues that people might be having with the idea of polymorphism, because polymorphism is a very powerful idea, where the type that we assign a variable to, we're assigning a key to an item object, is not necessarily the type that it is going to be at runtime. The type is going to be different depending on different scenarios. So if we were to say usable dot use, here's what happens. Usable dot use is going to invoke the method on IUsable. However, Because at runtime we are assigning to a new key, as a result, a method gets dispatched to the keys use method. And that's because at runtime, our item is actually an object reference to a new key. Now, in the example we actually have a little bit more complexity. So everybody, and at this point we did cover this, but we haven't covered this quite yet. When combining interfaces with inheritance, we actually assign it to a new green key.
Or blah, blah, blah to it.
Yeah, so we're assigning it to a new green key. A green key is an object that inherits from keys. So we have our green key object. I'm going to go ahead and nuke the mural for now. Goodbye, mural. It's a stupid word anyway. What we have here is actually a green key. That means when usable.use happens, this isn't the end of the story. Ultimately, at the end of the day, when I invoke the use method here, we're going to be asking for the use method in the context of an IUsable. This is implemented by the key class. The key class implements the use method on the IUsable interface. However, because that method is abstract, the dispatch actually goes all the way back down into our green key. So we start in the context of a interface where we're accessing this object via an interface. Ultimately, what's going to happen is, conceptually, this isn't actually what happens at runtime. At runtime, there's something called the virtual function pointer table that is a little bit more efficient than what I'm about to describe. But conceptually, this is what's happening. When we invoke the usable.use method, we're invoking it in the context of IUsable. Because the object that we're filling is a green key, the thing that implements the IUsable.use method is actually a method, an abstract method on the key class. This class is abstract. Ultimately, because the green key inherits from key, the method gets dispatched at the end of the day to the override on the green key class. Are there any questions about this, or has everybody been able to solidify what I discussed earlier in week 2 with what we've been doing so far? Because that would be actually nice if people have, but the whole reason that I'm going over it here is in the case that we can still do a little bit discussion about how this actually relates to the stuff that we've been doing so far.
The last row is usable. Usable.use. It's actually referencing the usable on the line preceding.
Okay, as is an interesting operator. It's basically like a cast. Are you familiar with this?
Ropey spelling, yes.
And it's okay if you're not used or not familiar with what this is doing right here. But NATO, are you familiar at least with the concept of casting? Because if you're not, that's okay. Then we can cover casting, which would be an interesting thing to talk about now that we've had some context. Because the as operator is essentially a cast.
It is, and it's like, how wrong would I be if I said it was very much conceptually like doing your int.try pass?
I mean, obviously there is no concrete correlation between the two things, but it is a very similar
No,
concept.
but conceptually, because the as, is, you know, it. Yeah, I can't explain it. It feels like there's a correlation to me. They seem like they do the same sort of thing in the same sort of way. Well, different thing, but in the same sort of way.
Sure. What the
safely is the key.
Yeah, what the as operator does is it says, is the item on the left an object? Now remember, the object that this is right now is actually the object we instantiated on this line by using the new keyword. This is what item is at runtime. It's a new green key. The as operator asks, is the object on the left convertible to the object or to the type on the right? Is a green key convertible to an IUsable? Now what we can do is we can look at our class diagram. Here's a green key. Our green key inherits from key, and our key implements IUsable. Therefore, at runtime, this object, this item object, which is an instantiation of the green key, is convertible to the IUsable interface.
But it doesn't just tell you whether or not it's convertible.
Right.
And this is where it gets useful. Well, say you had, if that line read IUsable usable equals dog as IUsable.
Yeah, if it said, like, let's say...
Or whatever, you know, something else that didn't inherit, that didn't implement IUsable.
So I just...
Then the as would it would say, no, you can't put a dog into an IUsable because you can't use a dog.
So what's going on here is the biggest difference is, I can go ahead and probably represent this in code better than on the whiteboard.
Yeah.
Let's say that we had a class called dog and a class called thing.
Well, actually, I'll tell you what, you could, if you really wanted to run the example, you could actually do it in place of an int.throw pass for user input logic.
The C# compiler is actually going to completely avoid me doing this. It's kind of funny. Because there's no way to convert from a dog to a thing, at least in the way that this is currently implemented. But if, for example, we had an interface
Nelson, if you did console readline as, you know, if int number equals console readline as int, would that work?
Well, I think that we're still...
All right, I was just trying to come up with an...
well, we're still talking about just casting.
No, it wouldn't. Yeah, carry on. Sorry, shut up. I'm probably just confusing things.
But anyway, so what we have here is we have a simple class hierarchy. We have two classes, a dog and a thing. Dog implements iStuff, thing does not. I mean, maybe this isn't... Hold on. How about we have both... actually, I might be able to do this a little bit better. Dog is not movable. Void move. Public. Void move. A thing is not movable, basically. So we can say IMovable dog equals new dog. And then we can have static void move. Let's bring in the common interface right now, item. An IMovable is an item. A thing is an item, but it isn't movable. So let's say we have a method called moveItem, and we invoked it with a dog. Or, sorry, we invoked it with a thing. I'll try this in the first one. And then so we try to say var movable equals IMovable of item movable.move. What would the output of this program be?
And assuming a read key at the end for when you want to show this. Just to save you having to stop and write in.
Given the class hierarchy, what output to this program will there be? And for people who are still confused about casting, I would really want people to try to work this out if they're new to casting. If I run this program, we'll get a nice little exception on line 37. We'll get an invalid cast exception. This is because we were trying to use a thing as if it were a movable. However, a thing is not a movable. Therefore, when we shoehorn the thing into a movable, we get an exception. Nato, does this bit make sense? I have a...
It's not the same as the move method that's in the dog. He's just didn't name it very well.
We are passing in an instantiation of a thing into a method that accepts an item. As a result, we get an implicit conversion. We get an implicit conversion between an object of type thing into a parameter of type item. Now, item doesn't have any members on him at all. Instead, what we're going to be doing is we're going to be trying to cast the item into an IMovable, and by doing so, we gain access to the move method. However, at runtime, we are going to get an error if the object we passed in as a parameter is not convertible to the interface that we're trying to use on that object.
Does that much make sense?
We're implicitly converting a thing into an item. This method,
which is fine.
Yeah, which is fine. A do stuff with an item can be invoked given any object that is an instantiation of any class that implements item. So we can invoke this method by passing in a thing or a dog, which is nice because it makes our method very flexible. However, inside of our method, we're kind of betraying the flexibility.
Very dumb.
Yeah, betraying the flexibility with a hard cast, where we're saying, I want item to be treated as if it were an IMovable. The C# compiler says, okay, I guess you know what you're doing. But the CLR at runtime will say, hey, wait a sec. The actual object that you passed in is not convertible under any circumstances to an IMovable. The object you passed in is actually typed to a thing, and a thing does not have a move method. Therefore, the item that you passed in this instance is not convertible. If I were to instead have passed in a dog, a new dog, this code would work. This code works because the dog implements IEnumerable.
And NATO, if you've been typing in BuzzNet, I'm not seeing it at all. Can you type something now in BuzzNet, please? Oh, okay. Not to worry, Chris. He posted in t'other place. You don't need to be panicking. This is it's very much a conceptual thing, this. The joy of the as operator is that it avoids that
Right.
that explosion happening.
Instead of using a direct cast, we're using an as. As a result, this variable will be set to either null or a proper instance of a movable object. As a result, we can check for it being null, and we can act accordingly. All right. So let's go on and move on to something simpler and actually incredibly useful as well. A lot of people have been seeing me use const and read only quite frequently. Oh, exactly. It tries to convert, and if it can't, it sets the value to null. If it can, it sets the value to a variable that's typed to what we asked it to convert it to. It sets it to an IEnumerable, which allows us to invoke the move method. See, we can't invoke the move method on an item because it doesn't have one. We have to invoke.
And I was going to say that's the where we've been rather silly in the first place doing this. Because if this is the functionality we want out of our method, we really should be passing in an IEnumerable.
Correct. But this is how the other example is working. It's using the as operator. It's saying, okay, you as the user told me to do something on an object. Now I'm going to use the as operator to determine if that object is capable to be interacted with in the way you wanted. If it is, I will interact with that object the way you wanted. Otherwise, I'll throw up my hands and say, well, too bad. So that's what's going on with the code.
And that's kind of why conceptually I find it to be similar to the try pass.
True.
Try pass, because it rather than just going, I can't do that, it's saying, I'm terribly sorry, I'm unable to achieve that.
Right. So completely ignoring every other bit of code in this entire project, just this code itself. This code is saying, if the user wants to use an item, then we're going to check to see if it's usable. If it is, as in if it's not null what was returned, then safely invoke the use method on that object. Otherwise, inform the user that he tried to do something stupid. We're doing the same pattern down here. We're saying, if the user wanted to examine something, try to make the object that he selected examinable. If you can make it examinable, then examine it. If you cannot make it examinable, tell them that they're not doing stuff right. So that's why I can use a red key, but I cannot use a mural.
And actually, Florum just came out with a perfect analogy to it, which is it's just like 20 questions. Animal, vegetable, or mineral? Is it animal? No. Is it yes or no? And it narrows it down.
Mm-hmm.
But cool.
Okay, so let's move on to read-only and const, because those are things that I will be using quite frequently and are quite useful and I like a lot.
Do const first.
Yeah.
Please.
I said yeah.
Oh, sorry, I didn't hear quite what you said, so I just assumed that you decided to say no. On past experience. Obdurate? Toi? Never mind. It's just killing time.
What do I think of AOP? I have conflicting opinions of AOP. Very conflicting.
AOP?
Yeah, AOP...
Is that a northern programming language?
No, AOP is called aspect-oriented programming. Typically an AOP library, what it does is it injects code between methods for you, depending on attributes that you apply to your methods. And on one hand, it can be very convenient. On the other hand, it can lead your code to be doing things that are not immediately obvious. So again, conflicting opinions. I've used it. I've used AOP techniques for implementing iNotify property change in WPF, which is quite nice, but I haven't found any other use for it.
That should totally be in more generally readily there namespace, in my opinion.
Oh, what?
That interface. iNotify property change, I think, is a wonderful thing, and it shouldn't be limited. It shouldn't be hidden away in WPF.
Yeah.
It's wasted on web developers. They only put stupid videos of cats up. Anyway, show me a constant, Nelson. No, it doesn't. 14159265535. I could go on.
Whichever. Still, though, constants are very straightforward. A constant, which can either be local, or it might also be on a class itself, are simply members or local variable things. They're not variables, they're constants. They can either be scoped to a class or they can be scoped to a method. And all they do is they provide a constant value for a particular thing. That's it. Constants must be assigned to something with the literal syntax. So, for example, you'll notice that this code is acceptable. Although hey there is a reference type, this code is acceptable. You may have const strings. You may also have const doubles, const ints, const floats, const bools, const anything with the literal syntax available for it within the C# language. Now, funny enough...
Colors, though. This is one I've come across quite a lot. Colors, you can't have a constant color in either X. It was certainly not in Unity, and as far as I recall, not in X and A either. But I might be wrong on that.
You actually, you kind of can. You may not instantiate an object and assign it to a constant. That being said, you can set it to null. So, as far as the rules of constness goes, a constant is anything that has a literal syntax for it. So typically you're going to be using constants for doubles and strings and floats and integers and stuff like that. You can do a constant of a user-defined type. However, you only have one valid thing to assign it to, which is null. So they're kind of
assigned to
useless.
it. That also explains why you can't do the colours then.
Mhm.
So I imagine that's a general thing with colours, because the only time you'd ever do it is if you're doing constant colour would equals, and then a colour, which you would have to define.
Why would I ever do this? I wouldn't ever. I mean, that's kind of stupid to use a constant with a user-defined type. But they are very useful for strings as well as doubles and stuff like that.
Certainly things like, message strings or anything like that. You can save a lot of space. You can chuck them off into a out of the way, really.
Another interesting thing about constants is, although they do allow things like the public modifier or the private modifier or the internal modifier, they do not allow the static modifier, because all constants are technically going to be static. As you see, the constant cannot be marked as static. They cannot be virtual, and they cannot be abstract, because that makes absolutely no sense. A constant may only be an accessibility modifier, followed by the const keyword, followed by a type, typically a built-in type, followed by an identifier, and then followed by an initializer that initializes that constant to a literal value. And that's all there is to do with constants.
So now for the less straightforward one.
Let's talk about read-only.
Only because they're not read-only.
Oh, yeah, by the way, you can't change constants. Yeah. I mean, that's...
Well, yes,
that's,
obviously.
That's, that's...
They're constant.
Thing. They're kind of constant. So let's talk about read-only.
Read-onlys are nearly read-only. But you can write them.
Kind of.
Once. Indeed, and tinker with is a phrase that should be used more often nowadays.
Read-only fields. Now, only fields may be read-only. You can have public read-only, you can have static read-only, you can have public static read-only. You can mix all those different modifiers in, but they can only be used for fields. So obviously they can't have virtual or abstract modifiers, because virtual and abstract modifiers cannot be applied to fields. A read-only field is a field that may only be assigned to during construction. It may only be assigned to during the construction of your class. That is the only time you can assign a value to them. Now, there are some important aspects to read-only. If I were to build this program right now, what would happen? So if I go to debug, build solution, we get a nice little build succeeded down here. For example, if I were to say var person equals new person, I can say person.addAddress 123, person.addAddress 456, 789. And I might have a method called public void show or display addresses.
You've got an error in your constructor.
I realized this, actually. I was about to fix it, but then you just had to go and tell everybody about it, didn't you?
Well, I imagine the big red squiggly line that told me about it and told them about it. But it's astonishing how often you don't notice those.
So you notice that this code works. Read-only does not in any way prevent you from accessing the members of an object that is read-only. Read-only prevents you from assigning that field to a different value. Now, if you remember, this value is a reference to an object allocated on the heap. The object itself can change as much as it wants to. The field itself may not. The field itself may only be modified during construction. But the object that the field is pointing to may change in any way that it sees fit.
You can't move house, but you can paint your house a different colour.
Yeah. So you couldn't make a new list string addresses in person. No. If I wanted to, outside of the constructor, assign addresses to a new list of string, you'll notice I get a nice little compilation error saying a read-only field cannot be assigned to except in the constructor or a variable initializer. So addresses will always...
Craftsman.
What?
I just said thank you to Craftsman for saying nice analogy to me.
Huh. So addresses...
I thought it was.
Actually, that was kind of a good analogy.
I thought it was good, yeah. I could hear the surprise in your, oh yeah, that works actually.
So addresses will always point to the same list, yes. Do you get an error if the read-only is not assigned to in the constructor? No, you don't. You get a warning.
You are dumb.
The field addresses is never assigned to and will always have a default value of null. But you won't get an error.
Will you now, presumably you'll now get an error at the add, because it's never been instantiated.
You'll get a null reference exception on add.
This is so cool, I actually understand this stuff.
But add address isn't part of the constructor. No. Because add address does not change where the addresses list is pointing to. It's simply working with the data that's been allocated on the heap for us. The field itself may not change. The field of addresses may never change. It may never point to anything else. It may only point to what is being defined on line 18. But that doesn't mean we can't reach in and alter the data that it stores.
Remember, don't think of addresses as the actual list of strings. Think of it as a sticky label stuck on that list that tells you that it's called addresses. That label, you can't change that. It's always going to be called addresses. It's always going to be there. But what's actually inside that can be added to, like you're doing on line 23,
right,
for instance.
I figure people in the C++ course would probably have a better time understanding this, funnily enough.
Well, we've been ramming it. That's why the C++ course was always going to be a longer course, because you have to deal with this stuff. C# does a lot of the nasty legwork for you.
Can you make the list bigger? Yes, you can make the list bigger, you can make it smaller, you can do anything you want to the list. The only thing you cannot do is make the addresses field point to a different list.
And instantly there, I mean, line 23 is making the list bigger.
Mm-hmm.
You're adding something to it.
I thought when you add it to a list, it makes a new list. Internally, it might. Internally, the data owned by the list may, if it runs out of space, instantiate a new bit of dynamically allocated memory to hold the additional value that you tried to stuff in it. But that's an implementation detail of the list class itself and is not something that is any way exposed to us. The whole point of having a list class is so that we don't have to manually reinstantiate arrays every time we want a bigger block of contiguous memory. The list class handles that for us, and it encapsulates a reference to an array. But that reference to an array is a field inside of the list. It isn't the field that's actually referencing the list. Could you do this to only have one player in a game class? When you make a new game, you construct a new player, but you never reassign it. You used to have only one.
Essentially to enforce never having two players in there.
Or never reinstantiating the player and setting it to the field. Well, yes. I mean, typically, read-only is something that you want to use. Because read-only is a compiler-level guarantee that you can reason about your fields in a constant manner. It's a compiler-level guarantee that first name and last name will never change. It's a compiler-level guarantee that this list of addresses will always point to the same list. And having that sense of security really does increase your ability to reason about larger classes.
But you can see why I'm always slightly, it does make my teeth grate. Because conceptually they're not as straightforward as you'd expect them to be. You'd think it'd be read-only, they're just read-only.
True.
Kind of like, they almost sound like an uber constant, but that's not what they are.
No. They're a constant that can be set to, but only in certain circumstances.
But cool. I don't know that there's many more ways you can...
Yeah. Basically getting around public setters, yet letting them work with when you need them to. Public setters. Well, yeah, because typically the classes that I create will very commonly have read-only fields. I still want to be able to set that data. I still want to be able to set a different first name or last name on every person I create. But in the case of the way I've built this program, I'm saying first name and last name may never change given a person that's been instantiated. Can you have public read-only? You may have public read-only. But a public read-only will only allow you to, like what you would expect. A public read-only may only...
Well, it'll give you a public access to
a
it
field,
from other classes.
But you still won't be able to set it. I commonly use read-onlys in place of constants when I want to make a constant user-defined object. So I could make a public static read-only person, default person equals new person default. Like I've said before, this is the only instance where I will find myself using field initializers and public fields. I've said this many times before when we're talking about field initializers and why I typically wouldn't use them. This is an instance, and like I said before, where I would use a field initializer, and I would use a public field. The reason is to me, this is a constant. This is exactly like a constant, except for it can point to a user-defined object.
Yeah, probably the concise way to think of them from that respect is that they're a constant that you don't know at compile time necessarily.
Right. It's not a compile time constant, but
they're gonna be a constant.
It's a runtime.
They will be a constant by the time. Yeah, by the time. But they're the concept of a constant almost. You're saying this once this exists, don't ever let it change, rather than with a constant where you actually have to say this exists and it is this. You can say this will exist and it will only ever be the one thing, but I don't know what yet.
Okay. Would this throw it into would start a person off by declaring a new person? Doesn't that create an infinite loop? No. It would create an infinite loop if the static modifier wasn't there. This would create an infinite loop because when I instantiated a person, this got instantiated, which would instantiate a person, which means this got instantiated, blah, 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 infinite loop. Because I made it static, however, it's not going to be an infinite loop. Line 10 sets itself. Yes. Again, I made this caveat when I was bashing field initializers earlier. that this is an instance where I do use field initializers. Because typically, read-only, whenever I apply read-only, I actually wouldn't apply read-only to a person type. Here's why. Can anybody guess why I wouldn't do this? Specifically because of the way the class person is written? Can anybody guess why I might have a problem with this? What, Kev?
Deed poll.
Deeple?
Deed poll, they let you change your name.
Well, it doesn't make, like, you change.
Wow, that's the sound of a joke going low overhead. Thank you, NATO.
The reason I would never do this is because person is not an immutable type. Just because we've created a public static read-only person, default person, this can still technically change because we can invoke default person.addAddress. This is not an immutable type, and I would not expose it publicly and statically to any other bits of my program. If it were an immutable type, then I would have no reservations of making it public and static and read-only. But because it is immutable, there runs into situations where this code will not work as expected when multiple threads of execution or bits of code that's far away from other bits of code might be editing the same object. So because it's not immutable, I would not do it this way. To make this immutable, I simply have to remove these two methods. As of right now, the person type is immutable because there's no way to change the state of itself after it's been instantiated. And that's kind of the goal with the read-only modifier. Why can I change addresses? We kind of already talked about this, where the addresses is an object. The object itself can change, but the reference to the object may not change.
Addresses is still the same list.
Right.
It's not changing. It's still the same list. It's just that there's different things written on that list. It's like if addresses was a stack of post-it notes or a calendar. It's still the same calendar, even if you put a tick by somebody's birthday in the calendar. God, that's another good analogy. I'm doing well today. Yeah. Nelson, say caveat.
Caveat? Anyway, can you do the same my list add on a const list? Const list may not be anything, really. You may make a const list, but there's only one thing you can assign it to. You can only assign a const list to null. You may not instantiate it.
Or vice versa.
The reason you may not instantiate it is constants are compile time concepts, not runtime concepts. You cannot execute code, and instantiation is an execution of code during the phase of compilation. Meaning the only valid thing you can set a const list to is the constant null, which isn't very useful.
So actually, the only useful things to set a constant to would be static classes. Because if you have to instantiate it,
well, even then that doesn't quite
then
work.
it's useless.
Even accessing members within a static class results in code being omitted.
No, I'm not talking about within. I'm talking about because you said obviously the only thing you can make that is null because you're not allowed to instantiate it with the new keyword.
Right.
Therefore, you can't use it on any class that isn't static. Because if it's not static, you have to instantiate it.
Well, you can't assign it. You can't do a const static class. Or am I missing? I'm confused.
No, static class. Bring that list example back up. Right. Const list in my list equals null because you can't instantiate
Right.
at runtime. Yes? So you can't use my list equals new list. In fact, if you undo a little bit more, it should say that.
Right, this is an error.
Yeah. Yeah. So presumably anything that isn't if it's not a static class, you have to instantiate it when you
Yes.
using the new keyword.
If it's not a static class.
Anything that
Yeah.
So anything that's not a static class can't be constant.
Right. But a static class can't be constant either.
Okay.
But that any class that you can instantiate cannot be done with this, per the definition of not being able to execute runtime code.
Sorry, Wolf, we're getting into kind of esoteric points on it now.
He is saying, though, I'm not getting the difference between first name and the address list. Strings are immutable types. There is not a single method on the string type that will let you change the data within it. Period. End of story. There is not a single method inside of a string that will allow you to change the data inside of that string. Meaning, the only way to get a new string value is to assign or to reassign a reference to a string to an entirely new reference to a string. Because that's the only way to mutate a string value, by adding the read-only modifier, we make editing this field impossible. However, list is not an immutable class. List can be mutated after instantiation, unlike string. Therefore, although the reference to a list is read-only, the actual data that's instantiated when we new it up on line 20 is not read-only.
Gotcha. So, what else is there to go through today?
Actually, Florence said something works for him that doesn't work for me, and I'm confused. Yeah, this code sample doesn't work for me. It doesn't compile. But, okay, so is that only list that does that? No, any mutable class, if it's read-only, you can still mutate it. Any mutable class. Now, ints, doubles, floats, strings, all of those are immutable types.
Florum said it worked because I didn't debug. Oh.
Okay.
What else have we got to go through?
We just have a talk about the Liskov substitution principle, but I'm probably going to have to step out for a minute or so. My voice is dying.
Yeah, that's what I was
miserable
thinking.
death. So I'm going to go ahead and hit pause, zoom button, and okay, we're back. So let's talk about the Liskov substitution principle, because the Liskov substitution principle is one of the #1 reasons why I dislike the idea of inheritance.
Who came up with it?
Liskov. I'm assuming.
Did he?
I'm assuming.
And what was his name?
Liskov.
And how do you pronounce it?
Liskov.
Can you say it again?
Am I saying it right? Liskov?
Yes, you are. You made such a fuss earlier about not being able to say it. I thought I'd rub it in.
Okay. Well, Liskov was obviously a very smart person who didn't like inheritance very much. So they made a nice little principle that seems very straightforward. Basically, the idea is, or to say it as best as I can remember, not the exact, we can find out the exact wording, but basically what it is any subclass must behave in a way that will not prevent the program from executing incorrectly if used in place of a base class.
There were one too many negatives in there, but yes.
Basically, a subclass or a subclass must be interchangeable anytime a base class is used. Does that make sense? Does that make basic sense? If you have code that works with the base class, and you run that code and you pass in a subclass. So let's say I have a person.
Well, actually, the previous example that we were doing, which you may well have nuked now, breaks the Liskov principle.
A tad bit.
It's right there. Because where we said we were being silly in that method that you called the move from IEnumerable on when we were passing in an I item. Or have I totally misunderstood?
I think you...
Because that to me sounds like it's breaking this. Well, we were passing in an I item and then calling...
That's a tad bit different scenario. That's a tad bit different. This is a more straightforward example of a case that actually follows Liskov's principle.
Okay.
The employee class, for all intents and purposes, may be used in instances where the person class is used. Therefore, it follows the Liskov substitution principle. Does everybody understand why the employee class follows the Liskov's substitution principle?
Well, in order to be an employee, it has to be a person as well. All employees are people, are persons.
Right. So when we invoke the print person method, we can use either a person or we can use an employee. So that's great. That's awesome. This is a good example of code I still wouldn't write anyway, but it follows the principle. Let's talk about a common mistake that people make. In mathematics, a square is a rectangle.
Yes, it's a special case of a rectangle.
So we might naively do this. So we have this awesome rectangle class, and you might think, well, a square is a rectangle just with some special stuff added onto it. How do I express a special case of a thing in a programming language that supports object-oriented features? Well, I'll just use inheritance, derp to derp, and you end up with this.
I wouldn't have said derp to derp.
So the first thing I'm going to do is I'm going to say that set dims is virtual, and I'm going to make these two fields protected. Because we really want to take advantage of existing code that works with rectangles, but we want to work with them as squares. So I'm going to make a square, and I'm going to have it implement or inherit from rectangle. But what is the fundamental thing that makes a square different from a rectangle?
Width equals height.
Yes. So let's go ahead and enforce that invariant. I have just...
See, I wouldn't have done that.
Well, I'm showing you code that breaks a principle. I hope you would.
Oh, okay. Right, cool. I was just looking at it, I really wouldn't do it this way. I really wouldn't. Carry on.
I have just broken the Liskov substitution principle. And can anybody guess why? Can anybody see why I might have broken it?
Here's a hint. It's quite close to where he's broken the program. Well, no, see, I'm quite happy in a minute to say what I would have done, and then you can tell me why that's bad on 12 levels.
I have just made a subclass that will not behave the same as the base class. These two classes...
The base class doesn't throw an exception at any point.
Right, whereas the subclass does. I've broken the principle by making a situation where if I were to pass in a square as a rectangle into a method, something like this, get dims.
While Nelson's typing, Segful, people can see you, so if you can't see them saying they can see you, then you need to refresh, doesn't it? If you can, and you're just being silly, you need to shut up.
Can anybody see the problem now? This code is acceptable. This code may compile. It will compile, in fact. But it introduces an example of a situation where you may have written code in terms of a base class that for all intents and purposes should be valid. But we're now introducing a runtime possibility that this code may not be invalid. The writer of this getDims method may have been a completely different person working on a completely different part of your 2 million line long code base. And he may have said,
Sure.
You what?
Well, no, absolutely. You should. This comes down to what I've said before about writing code for somebody else. Always write code as if it's for someone else. getDims takes in a rectangle. So you go and look at the rectangle, and you go, okay, rectangle.
Can have any width and any height.
It's any width, any height, fine. Okay, I'll write this getDims method for this program, and this is what it's going to do. And it's going to take in a rectangle. So when you come to edit this, you go and look at rectangle to see what you're taking in and what you've got to play with. You might know, that square class could be in a different CS file. It could be anywhere.
It could be a different project.
Yeah. There's no reason that you would. Yeah, quite. There's no reason you've even got it on your particular build of the project.
There's no reason you even have it on your hard drive. The getDims method could be a library method from a third-party vendor that provided you a compiled DLL, and you went along.
It was written in C++ in the first place.
And you go along and you subclass out the rectangle, give it an additional invariant. The invariant being width must equal height. Now you have broken existing code that on the surface looks valid. Because the developer of this didn't think to add validation if it's a square. This is a violation of the Liskov substitution principle. This code will compile, but as you see, it may not work.
Yeah, and as Segful just pointed out, that's not their responsibility.
Actually,
you've no point told the.
I do want to really quickly point this out, especially for people watching the video. I did make a typo that nobody noticed. Seg fault, Gavin.
Hey, I've been told not to say stuff, and I did wonder why you made it virtual, but I assumed that you would be coming back to that.
I'm doing a method hiding, not an overriding. I should have used override. Anyway, but now you can see I run this code, and at runtime we get an exception because some person thought, well, conceptually a square is a rectangle, when they didn't quite realize the fact that creating a subclass that accepts fewer valid values than the base class, they have inadvertently destroyed code that was previously considered to be perfectly valid. A subclass... What?
No, carry on.
A subclass should never enforce additional invariants on the base class. This fact alone severely limits the usefulness of inheritance. And I'm not saying it shouldn't enforce additional invariants in the base class out of some, strange sort of ritual and adherence to archaic principles. I'm saying that if you do this code, you will run into exceptions, you will run into issues, you will not be able to easily debug it. This is a principle, this isn't quite like SRP. SRP has many different interpretations, can be applied to many different levels of granularity, and may sometimes be completely and utterly not adhered to for the purposes of simplicity or the ease of writing your code. Typically, you should follow SRP all the time, and if you don't, you will generally run into errors. However, breaking this substitution principle will inevitably lead you to problems very quickly, and it should never be broken. Right, and as Segfault points out, if you do follow this principle, then you'll end up with subclasses that have no additional invariants. There's only one solution to making this program not breaking the substitution principle without changing the way the program is organized. And that one solution is to remove the invariant I have specified on line 29 and 30. However, being good developers, we don't want to do that. We want our squares
because it's no longer a square.
Yeah, because we're no longer enforcing that. We've just broken the concept of encapsulation by allowing other people to edit us in a way that isn't valid. So it puts us in a bind and puts us in a situation that we cannot properly express without breaking the substitution principle because we were so tied to the concept of inheritance.
Because I've come up with two different ideas about how to go about it as I've been sat here. One, my favourite, which would probably be to add a property saying is square to rectangle and just ditch the square class.
That would be a valid solution.
Or alternatively, have it implement I rectangle and have it implement I symmetry of a certain type, and then do it go up. But that would depend on how in-depth your program was, but you would do it by symmetry.
Honestly, there's a million ways we can express this. The way that I would probably go about doing this is identifying the true problem. And the true problem here is that we have this concept of setting dimensions that may or may not be valid. The current thing that our program expresses is the idea that certain shapes should have different constraints on their dimensions. Therefore, I would probably end up with a rectangular shape class that has a property called dimension validator. And the dimension validator is an interface, and you may set the dimension validator to anything that you like. Other code working with the rectangular shape class would, instead of just setting dims like this naively, would first ask the dimension validator if it is indeed a correct result, a correct operation. That's the way that I would go about expressing this, at least keeping true to what the current behavior that we're currently expressing. Because again,
that's the thing. At the end of the day, I mean, a square and a rectangle are fundamentally different enough in terms of how you would use them in code that you probably wouldn't want to do that in the first place. You just have a different type.
Yeah. Well,
there isn't actually very most when you actually start looking at what sort of operations you might do with them, it's kind of
you would want the concept of a rectangular object, because you typically would want your squares to work in the context of operations that are typed to rectangle, but only if those operations have to do with reading values, not writing to them. Because the fundamental difference between a square and a rectangle isn't how you can represent them graphically or how you can reason about them dimensionally, but what you can assign to them. So that's where I would come out with a dimension validator interface that provided different implementations depending on the specific instance of a shape you're working with, so that other code may delegate to your dimension validator, and so you can swap out the implementation of your dimension validator depending on the context of the shape you're working with.
Mm-hmm.
Because that's the problem we're truly trying to solve here. I still want to be able to write code in terms of a rectangle and have it work with a square and a rectangle. I still want that.
Yeah.
But because of this problem we've expressed, I would actually encode the concept of dimension validation directly into the class itself, as opposed to leaving it up to inheritance. Again, This is an example of composition over inheritance. The difference between a square and a rectangle isn't what information they contain, but what information they can accept. Therefore, instead of using inheritance, we can use composition to properly express that goal.
That's what I was wondering. If on line 25 you add a comma, well, you turn rectangle into a...
I failed so
Yes,
hard.
because
on
you'd
that
have to have a
composition
non-square rectangle as the concrete class for rectangles. But because if you turned it into an interface and then also had an I symmetry interface that enforced width equaling height, would that work?
Well, something you could do without even using interfaces is do this. Instead of this method being virtual, we'll have a public virtual bool
Okay, and override it on the square class so that it actually does something.
Yep.
Nice.
So we would say public override validate dims, and we would say return width equals height. Now we're no longer breaking the Liskov substitution principle because
so that makes sense all of a sudden.
Yep. Because if we jumped into the rectangle class, we'd immediately see the validate dims method, and we would know that we have to validate the dims before we set them. Otherwise, we'll get an exception. So that allows us to represent this code. So now I can turn this into a while loop. And say, if not rect validate dims with height, or sorry, if, then break, otherwise console write line what are you yelling at? Derp. So at this point, I have now created the rectangle class in such a way that does follow the Liskov substitution principle, and I have forced any people who work with this class, sure, they can pull off the width and the height as much as they want, which allows me a great amount of flexibility. Because now, let's say I have a render rectangle method. I can now pass in a square or a rectangle into it. I've doubled the functionality of that method. But when they go to set the dims, we have now provided a consistent and standardized way to validate them before we actually go to set them. So
cool.
Now we're properly following the principle.
Just to top off what DStew said in Firefox, actually, a rectangle is special, but it's not that the opposite sides are of the same length that makes it special. A rectangle is only special because it's got right angles and has opposite sides of the same length. A rectangle is a special case of a parallelogram.
Right.
The thing that makes a parallelogram special is that the opposite sides are the same length.
Yep.
It's all about the hierarchy.
However, representing parallelogram would get a little bit too far from the example.
Rhomboids to you too, sir. Sorry, I was enjoying the maths. Let's go back to the programming.
If square only had width, would you? If square only had width, see, here's the thing.
If square only had width, validate dims would no longer correctly override because you need two arguments.
Right. Here's what I wanted to do with this code. I wanted to create a 2 million line class library that depends on the concept of a rectangle to do a variety of useful, awesome calculations, renderings, it does everything from make me coffee to
Minecraft.
pick up, groceries. This 2 million line code base does everything I want, and it does it in terms of a rectangle. But I decided that I wanted to add some additional invariants to specific types of rectangles, because I noticed that allowing the user to type in non-square rectangles in certain cases caused problems. So instead of representing this code in a way that protects instead of representing this code in a way that adds an invariant, I'm representing code here that overrides an invariant that's already present in the base class. Anybody who's using the rectangle class properly is always going to invoke the validate dims method before invoking set dims. I mean, they don't have to, but that's a part of the contract of the class. Like Gavin was saying earlier, a person reading this code or writing this code will jump to the rectangle, and that's all they're going to see. They're not going to see any of the subclasses. So as a result, everything that makes this rectangle a rectangle and everything that we might want to extend per this rectangle must be expressed in the base type. Otherwise, we run into situations where we will be adding invariants that could inevitably cause my program to fail and not pick me up my groceries properly.
Cool. I think we've hammered that home.
Well, actually, Florin brings up a great point. But wouldn't that mean you need to foresee what the user of your base class will implement via interfaces? Yes, it does. It completely 100% does. That's why expressing your code in terms of inheritance and in terms of base classes is going to most likely lead you down a road that will make it easier for consumers of your application or class library to create invalid classes that in some way make your program get invalid during runtime. Makes your program state invalid during runtime.
An emergency smash glass for blue screen of death.
Yeah.
Anytime you're interacting with a user, you don't want them. You want to stop every possible option for them to mess up your nicely written program. Essentially.
What situation would you want to use class inheritance? I think I have covered this before. I have used class inheritance in the past when there's only one method or one very, very, very small bit of code that I want to change. That's a very rare instance. A recent example would be in the Photon framework code that I put together, I have this class called server connection. And I like being able to reuse my server connection in the context of Unity or non-Unity projects. However, there's one line of code in that entire class that will only work when it is acceptable or it is not constrained to what thread that server connection class is running on. I did find, now I could have used composition inheritance. I could have done that. And that would have been fine. That would have been great. But instead, I just got lazy and changed that one line of code via inheritance. The only valid instance of a case where I'm not being lazy and using inheritance is when I have an interface and I have a bunch of additional functionality that I kind of want to carry along with classes that implement that interface. Now, I don't want to constrain that you must implement a base type in order to use the interface. But sometimes I do feel that it is more appropriate to express helper functionality in terms of inheritance rather than in terms of composition.
And actually, that's kind of why I threw in the abstracts that you then inherit from in the keys example. Because the key thing with the way that worked, have you still got it available there? Or or the Visual Studio. But is the fact that the abstract is in charge of composing the interfaces. It says out there that the abstract implements I think it was the item, IUsable, and IMovable interfaces. That groups, that sort of defines what a key is. But then, because that's an abstract class rather than an interface, you can put functionality into it. So that was where you would put your general key functionality. That was where you might put your, your unlock code or your whatever, however you were determining what the functionality of keys in general are. Yep. And then when you get to the actual specific ones that you bring into the game, has your Visual Studio died? Is it
no,
just,
it's
there we go. Yeah, stuff, words.
Well, I do want to show people really quickly something, and you don't have to understand the complete context of what I'm going to show you, but you should see how this relates to what we've been discussing. ASP.NET MVC is a open source web development framework made by Microsoft. And they have these concept of controllers.
Sorry, I just looked at your solution explorer.
Now, the controller class is an abstract class. If I click on it and jump into the source of it, you'll notice it is an abstract class. It actually inherits from another abstract class called controller base. Controller base inevitably implements iController. The entirety of ASP.NET MVC only cares about this interface. It only works with controllers in terms of this interface. But here's a bunch of additional functionality that is added. A bunch of really convenient helper methods. You'll notice that they're fairly anemic. These helper methods are very, very straightforward and simple, and typically just delegate off to another bit of the framework to perform their operations.
They're middle management, really.
But what it gives you is a sort of DSL within your own language. You'll notice that my action right here, my action result index, you don't have to understand what this is, but you'll notice I do something called return view. Now, if I look at the code inside of return view, it's actually performing some repetitive operations that I wouldn't want to do over and over and over again every time I wanted to return a view result. So although the iController interface is still implemented by my class, by my home controller, I get a bunch of nice little easy-to-use functionality that allows me to write my controllers a little bit cleanly by using a base class. This is typically the only instance I will find myself using interfaces or inheritance unless I'm being lazy.
You will come to points where you essentially would like to be able to have an interface. You would like something to be an interface, but because of you want to be able to use it again over and over and implement it. But there will be something that you would really like, or several things in that case, that you want to have some functionality in there by default. You cannot do that with interfaces.
The important bit to realize, though, is that you should always still hide behind an interface. Look how simple this interface is. This interface gives you a lot of power and flexibility within the ASP.NET MVC framework, and allows the rest of the code inside of ASP.NET MVC to be able to reason about your controllers in a very standard and easy and straightforward manner. This is all that ASP.NET MVC cares that you implement. But I get to write code a lot cleaner by these two classes. These two classes provide me the opportunity to write cleaner code, even though the rest of the system only cares about this controller interface. So that's an instance where I would use inheritance.
Right, we're heading on. We've been going for a while.
Yes, we
Let
have.
me put it that way. We are heading way up. It's 4:45. You should just stop talking.
And is breaking the Liskov principle, is that replacing it with another one? I don't understand what you mean by that. The fact is that this does break the controller class does slightly break SRP, but I feel that it's kind of okay because even though it does break SRP to an extent, all of these methods just delegate to another component within the system. So it's not the controller's responsibility to know how to do things, but it does provide you some basic rudimentary code. That would be typically repetitive. The responsibility of doing model binding, for example, with the try update model method, is still the binder, the binders, and the get binder method, and the bind model method, and the model binder.
Sooner or later,
that's all being done by somebody else. It's just the controller. You what?
For the vast majority of programs you write, you're going to really struggle to not have anywhere in your program that takes in a lot of stuff and throws out a lot of stuff, I would say. That's and certainly, and trimming down the fat on those parts of your program is the hardest part of coding better. But as with all these things, it's a principle. It is a principle to be followed.
Right.
It's not, the universe isn't going to explode if you don't.
This code does not break the substitution principle because this execute method is the only thing on the interface, and this execute method will typically work just fine. Typically, as in, it can still throw an exception, and that's a valid aspect to invoking the execute method because the contract that the controller interface provides. It can set a result on the request context. But think of it this way. The fewer methods you have on an interface or a base class, the fewer chances you have to break the substitution principle. But anyway, so moving on to homework, because this short class ended up being 3 hours of recorded time.
Yeah, my brain shut down about 20 minutes ago. I mean, proper 7 at the second level shut down. It shut down about half an hour before class started normally. Not so much short, but easy moves. This was a light class.
Yeah. The homework is going to be really straightforward, and I kind of want to expand it a little bit next week because we're not going to be having a class next week. And the reason is that there are things about your program, your game that people have been developing is going to be diverging from what I've been building. Probably. Now, I will be...
More than a little.
I'm pretty sure
I would imagine.
We will be providing the content that has been put together for this game. That doesn't necessarily mean that everybody has to follow this exact same content. I like having content here because it gives me perspective on things to implement. And the things that we do implement in the code is going to change. What I really want to see people do here is implement a usable or express the concept. I know I'm getting a little bit abstract, but we will have two open office hours next week to discuss this. I want people to express the concept of using an item in a room, allow the user to pick up an item from a room. Allow the user to drop into a room. And I'm going to actually switch this last.
I'll let you post the thread on this again. Seeing you did such a wonderful job last week. There is an IEnumerable.
And actually, one last thing, of course, is going to be
Actually, you could give them specific functionality to implement, as Musaru just reminded me via BuzzNet. You have dropped the red ball in the blue room.
okay.
Create 2 rooms. A red room and a blue room.
This room is blue. Somebody better have got that. Really, come on. Come on, people. Come on. Whatever.
The object of the game, the most exciting game ever made, is to find the green room.
And no, that wasn't from Liar Liar, it was from Cube 1. And Cube 1 is a great movie that I'm surprised more people here haven't seen. Okay, so yes, Cube. The first Cube. Great movie. Yeah, probably. They only had like one room? Because it was a single box. Okay, so here's the homework. Any questions about this? Notice these question marks. These question marks are suggestions. If you're following along with a similar architecture as me, then you might want to look at those hints. Otherwise, I really want to start seeing people diverge in a way that they feel comfortable.
I think you were going to say, otherwise, good luck to you. Don't come crying to me when it doesn't work.
Okay.
No, they're just not radioactive, they're just not joined together.
Well, they should be joined.
And there will be special laughter at anyone who decides to put in nice ASCII congratulations screen pictures.
Okay, so how's everybody feeling? Because this is about it.
Special props to Wolf Knightley for making a coding joke. He's learning. Same deadline as the...
C++, so next Friday.
No, wait a minute. No, because he gave it until the following Friday. But of course this will be the following, so it'll be essentially 2 weeks today. 2 weeks to Thursday.
Okay.
Hello?
Okay.
Has anyone else lost sound?
I have not. I hear you. Okay, so that's about it. And I think, yeah, so I guess we're going to see everybody later.
Cool. Oh, what were you thinking about doing? Were you going to have... were you going to replace the class times with
I was thinking
hours,
that.
one for each? That would be the easiest thing to do, I think.
Yeah, I was thinking that. Okay,
So-
but I want to stop the recording. So, yes. So, goodbye, every future person.